Page 415. 415. Oh, did you find something that you didn't know what it was? Uh-oh. All right. Real world link. Factor linear expressions, lesson 8. A rectangular yard is being separated into 4 equal size sections. So right away, there's a clue that there's going to have something to do with division. For different items at a yard sale, there's housewares, toys, clothing, and books. The area of the whole yard is 8x plus 12, because that's how people measure their yard, square meters. You can find, or how can you find the area of each section of the yard sale? I want my notes so I don't make any mistakes. There we go. You're going to be dividing. Divide. We'll do. Divide 8x plus 12 by 4. Because we're dividing it into equal sections. So we just divide the whole thing by 4. What is the area of each section? Does anybody have a guess? What do you think? You are 100% correct. Yes. Yes. So it says explain your answer. So we're going to write that down. It says, what is the area of each section? And explain your answer. A lot of students are not doing the explain your answer portion of the Schoology question. So you're not going to get full credit if you don't answer the full question. So divide both. You know what? Monomial. Defined. Yep. We're going to find that on next page. On next page. Divide each monomial by 4. Eight x divided by 4 is equal to 2x. Twelve divided by 4 is just 3. So each section is 2x plus 3. So each section is 2x plus 3. So when we're doing this part, you're good with watching. I'm going to post these, but just make sure that you're doing the examples when we get to the examples. People, you need to find your volume 2 books. There's like 4 people in every one that, 4 people in every class, or at least 2 people in every class that they're not using their textbook. I need you to follow along in your notes with your textbook. Right, please write a note somewhere. So, the algebra tiles represent the area of the entire yard sale. Fill in the length and width. Write an expression that represents the area in terms of the length and the width of the model. So for this top box here, there are 2 x's and 3 integers on the top. So I'm going to have 2 x's and 3 integers on the top. And what would go along the other side, since you're doing the area, you would have to think how many times is that 2x plus 3 happening? And it's happening 4 times. So we would have 4 times the quantity of 2x plus 3. And that would be the whole area of the yard. 2x plus 3 happens 4 times. She is really proud of her yard sale pickup. Find the GCF of monomials. A monomial is a number, a variable, or a product of a number and one or more variables. So if it has addition or subtraction with it, it's not a monomial. The prefix of monomial, mono, what does that mean? Mono, or what does you think it means? One. Yep. Single. Monomial. So if you have x plus 4, that's not a monomial. However, if you have 25, or just x, or 40x, those are monomials. So we're going to be factoring those monomials today. So we're going to be doing a factor tree. Apparently, in the past, math teachers are calling it a ladder. But when you do a factor tree, it starts in one and goes out to a bunch more. So it looks more like a tree rather than a weird-looking ladder. Yeah. So you're going to hear me call it a factoring tree. A factor of a number means to write it as a product of its factors. So in other words, you multiply these things together, you get the big number. You multiply each factor together. Each prime factorization, multiply them together, you'll get the number that you started with. A monomial can be factored using the same method you would use to factor a number. The greatest common factor, or GCF, of two monomials is the greatest monomial that is a factor of both. Okay, that's a lot of ways of just saying this. There are two significant sections of this homework. The first one is factoring monomials. The next one is dealing with working backwards from the distributive property. So for this one here, when they factored 4x and 12x, and if you're not remembering at the moment what the factoring tree would be, if I had 4x, I'm going to factor the 4 as being 2 and 2. Yep. I'm going to factor the 12x. 2 and 6. Oops. 2 and 3. And once I get a prime number, I'm going to circle that. Whenever I have an x, I can't factor that out if it's just by itself. So if you recall, I'm sure a lot of you just went, ah. Yeah. So for these ones here, 4x factored out to have a 2 times x. 12x factored out to be 2 times 3 times x, and that's represented on the right side of the screen, and that's what's circled. And what happens with this one is you're going to circle the common factors. What they mean by common is it's in both of the factorization of the monomials. So they circled in red. There's 2's that are shared. There's another set of 2's that are shared, and also it shares an x. So to find the GCF of those two monomials, you multiply one of the 2's times another one of the 2's, and you multiply it by the x. So it comes out to be 2 times 2 times x, or simplified, 4x. Similar example here. I'm not going to do the factorization of that for time reasons, but 18a factors out to be 2 times 3 times 3 times a. 20ab factors out to be 2 times 5 times a times b. The common factors there, they share a 2 and they share an a. So all you do is multiply the 2 times the a to get 2a. $12CD factors out to be 2 times 3 times c times d. 36D, I'm actually going to factor that one out so you don't forget how to do these. C and D don't factor. And there are many different ways that you can do this factorization. You can do, let's see, we could have 15, 16, 17. You could do 18 times 2. You can do 6 times 6. It doesn't matter where you start because you're still going to end up with the same factor tree at the end, the same results. So there's the 2 times 3 times c times d. When you're doing the factoring list, like it is over here, when you're doing that list, you're going to start with the smallest number, and then you're going to go in alphabetical order. So they have a common factor of a 2, and a 2, and a 3. Notice how this 3 is not a common factor. It's only in the 36 CD. It's not in the 12 CD. Then there's a C and a D that is common. You only are multiplying together what is circled. So 2 times 2 times 3 times C times D is going to be 12 CD. Any questions so far? Okay. Now this isn't as challenging as we've had recently. However, this is more time consuming. So let's do some practice of find the greatest common factor of each monomial. I'm going to put the 12 over here just so I have more room. 12 is 3 times 4, 2 times 2, circle. 28C, you can do 2 times 14, 2 times 7. Now I'm going to list these out. The prime factorization of 12 is 2 times 2 times 3. The prime factorization of 28C, can't forget that variable, 2 times 2 times 7 times C. I'm going to use a different color just so you can see it easier. I have a common factor of 2. I have a common factor of 2. And that's it. So I'm going to, yeah. Good question. Since there's a 2 that's common and another 2 that's common, the GCF of those two is 2 times 2. Yep. Not to be confused with multiplying what's in the circles, like all 2 of them, like the 2 times 2 times 2 times 2. It's just they have a common 2 and another common 2. So 2 times 2. Five times 5. 3 times 5. So 25x factorization is 5 times 5 times x. 15xy. 3 times 5 times x times y. I have a common 5. I have a common x. When I multiply 5 times x, it's just going to be 5x. Yeah? Yeah, that's why I circled 4. Yep. I guess it's not too evident because I'm using so many circles. Let's do box in my answer. Yeah, it just takes a while. Yeah, this. Because you guys are really familiar with your. Do we need to do C? I have C done on the paper, on the notes I'm going to post on Schoology. So, I mean, it's just going to be the same similar situation. The only difference is there's an M and an N on it. All right, part two of this homework and lesson. You can use the distributive property to work the backwards strategy to express linear expressions as a product of its factors. A linear expression is in factored form when it is expressed as a product of its factors. So, for example, we're working backwards to figure out what is the greatest common factor. And whenever you find the greatest common factor of these expressions, that's going to be on the outside of the parentheses. So they realize that the GCF of 8x and 4y is 4. So they pulled the 4 out of the parentheses to have the final, to have it be 4 times the quantity 2x plus y. Because if you were to distribute the 4 into both of these, you come back with 8x plus y, or 8x plus 4y. So far, my students have not really liked this method here of using a model. So we're just going to go to method 2. So we have the expression 3x plus 9, and we're trying to find the greatest common factor of those monomials. So they're going to take each monomial and factor it out. 3x became 3 times x. 9 became 3 times 3. The greatest common factor of those two monomials is 3. So the 3 goes on the outside of the parentheses, and what's left over, what is not circled, is going to be in the parentheses, and x, the operation is a plus sign. So it's plus, and then what's left over in the other one, 3. Okay, when we do the examples, it'll make more sense. Factor 12x and 7y. Once again, they factored 12x, got, no button. That's how they got the 2 times 2 times 3 times x. And y is 1 times 7 times y. That's the only time you're going to see the number 1 factored out. Okay? You don't need to factor out a 1. Because of the multiplicative identity property, we know that if we multiply anything by 1, it's going to still be that same thing. In this situation, no common factors. Notice how we can't circle anything. So that's your answer. They cannot be factored. And there are 2 questions on your homework that's the answer to it. What do you got there on your lap? Okay. So now we're going to factor each expression. So we have to do the factorization of each monomial. This is just going to be 2 times 2. Keep that x. 28, there are multiple ways that you could do this. You could do 2 times 14 if you wanted to. Then again, I'm going to list them stacked on top of each other. 4x, 28, 2 times 2 times x. 28, 2 times 2 times 7. My common factors with this one, there's a 2 and there's a 2. I'm going to be multiplying the 2 times 2 to get 4. So that means that 4 is going to be on the outside of the parentheses. 4 is going to be on the outside. It's an ugly 4. That's better. Now I have left over an x and then a y. Sorry, what? And then a 7. I have an x left over. My operation is subtraction, so I have to keep it subtraction. Minus 7. 4 times the quantity x minus 7. So we're doing reverse distributive property, because if I were to put that 4, if this was the distributive property from 2 weeks ago, if I put that 4 into the parentheses, I'd have 4x minus 28. Next one. That one's already worked out. 3 and 11. 3x. 11. 3 times 11 times y. I have common factors of just a 3. So that means that 3 is going to be on the outside of the parentheses. It's going to be 3 times. I have an x left over. My operation is addition. Yep, 11y. I'm not going to box that one in because it's getting too congested. 4x. I'm going to stack them up now so I can circle my common factors. 2 times 2 times x. 5 times 7. Uh-oh. So what can we do? Cannot be factored. You wouldn't even have to make it to this step necessarily, because as soon as you see that none of these circled in, factors are common, you can just stop right there and say cannot be factored. So the reason I'm telling you that there's only 2 questions on the homework that cannot be factored is because I had several students that were writing simplified when we were simplifying expressions. I had them write simplified like way too often because I don't think they wanted to do it. Like they didn't want to get the work done. Okay, we're skipping example number 6. Here's what I'd like you to do. I would like you to please do number 2, number 3, number 4, and number 5. I've had a lot of students skip to the independent practice. This is the guided practice. Okay? The guided practice. Yes, sir? Sorry. 2, 3, 5, and 6. I want you to do 2, 3, 5, and 6. Please do that now. In a minute, I'll start writing down what you should have. I'll do 2, 3, 5, and 6. So you not only don't have your book, but you also can't read that. So, do you have glasses that you're not wearing? Okay. So another solution to that would be to stand up and walk to the board then to write it down. I do have numbers 1 and 4 done on the notes I'm going to post on Schoology. So if you want more examples, I have all the examples done on that page, that PDF that I'll post. If you don't have the same factor tree, that's fine. As long as you just have the same factors that you're done with. There's multiple ways you can multiply things together. What are you reading? What do you have? Is it a note? Is that what it is? Okay. So let's put that away, please. Gotcha. Okay. We're being suspicious, so put that away, please. Wow. Days that I don't record in here, you guys are never having issues like that. It's twice. Okay. So once again, if you have a different factor tree, that's fine. But as long as you have the same factorization, you're correct. 2, 3, 3, C, D, 2, 3, 5, C, D. These guys are in common. 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 Comes out to be 6. I'll go over here. 2 times 3 times C times D equals 6CD. It's just a lot of writing to get to a single answer. That's why this homework assignment is unfortunately going to probably take you longer than normal. But you don't have to, obviously you're going to do the work on paper. You do not have to show your work on Schoology. You can just enter your solution. Yeah, enter your factorization, enter your GPS, whatever it might be. Or GPS, GSF, GCF, my goodness. It's not matching. I could do matching on a lot of them, but the thing is, I'd want to make sure that you guys had an idea. Like I would put something that would be a common error, but that would just take longer than me just going through and grading all you guys' questions. Two times 6, 3 times 3. With these ones, this is where you're finding out what's in common, and that's what stays outside the parentheses. Common. Common. Five. Wait a sec. What did I do wrong here? No, that's not common. They don't have anything in common. Cannot be factored. Because they don't have anything in common. Does anybody need to still see 2 and 3? So I can actually write on it. It's not below my elbow. 14, 2, 7, 16, 2, 8. 4, 2, and 2. Oh, that's too thick. You get thinner. There we go. 16y. 2 times 7 times x. 2 times 2 times 2 times 2 times y. I have common factor. I have a common factor of 2. So that means that 2 is going to go on the outside of the parenthesis. Then what I have left over is 7 times x. 7x subtracted by 2 times 2 times 2 times y equals 8y. Any questions on those? I think you guys got this. It's just timely, time-consuming. All right, the last thing we're going to do, the greatest common factor, or explain how the greatest common factor is used as a factor of to factor an expression. Use the term distributive property in your response. So, works backwards. To pull the GCF reversing the distributive property. Sorry. I didn't even do that in your face.